In class.
Okay, anyway, so this is how the definition of the derivative looks for the sine function, okay? So like I said, we're just plugging in sine as our function here to this first step, all right?
Oh, and then they
Okay.
did this sine A.
And then, right, this comes from the sum identity, which you learned last year in trig, which is that the sine of an angle plus another angle is the sine of the first angle plus the times the cosine of the second plus the cosine of the first angle times the sine of the second. And that's not something that we expect you to remember, but that's where that comes from, okay? Then they're going to take this and break this down into two separate fractions. Sine of h cosine of h minus sine of x is this piece here, plus cosine of h sine of h over h is this piece there, okay? The reason why they did that is because now they can factor out a sine of x from here and a cosine of x from there, all right? Which means that this becomes the limit as h approaches 0 of the sine of x times the limit as h approaches 0 of cosine of h minus 1 over h plus the limit as h approaches 0 of cosine of x times the limit as h approaches 0 sine of h over h, okay? So this is not something that you necessarily wouldn't be expected to come up with on your own. And maybe you only understand 25% of it, maybe you get 75%, I don't know. But this is where the answer comes from, okay? So we're not done. We need to evaluate these limits, all right? Two of these four limits are easy to evaluate.
I'm guessing it's just the sine over sine.
What's that?
Never mind.
Okay, since this piece right here doesn't have an h in it at all, the limit as h approaches 0 of the sine of x is just going to be the sine of x, okay? So that's what they've got going right here. And same thing with this piece right here, since it does not have an h in there either. If you plug in 0 for h, there's no like h to plug 0 in for, right? So this just stays as cosine of x, okay? And so then that leaves us with two things that we need to actually figure out with the h's. Limit as h approaches 0 of sine of h over h, and the limit as h approaches 0 of cosine of h minus 1 over h. This bad boy right here is already on your note card. Okay? This is a limit that we came up with when we were talking about limits in chapter 2. The limit as h approaches 0 of sine of h over h is 1. Okay? So far what we are able to do is we can take and rewrite this as this piece right here is just sine of x. This piece right here is currently a mystery, but we'll figure that out in a second. Plus, this piece right here is cosine of x. And this piece right here is 1. Okay? So now we just need to know what the limit as h approaches 0 of cosine of h minus 1 over h is. Any guesses? Negative sign? 0?
Yeah, doesn't it have to cancel out?
Yeah, it has to cancel out for that to work. So here's the math that they do to figure out this limit here. You want to follow along this bouncing ball?
No.
So we're starting with the limit as theta approaches 0 of cosine theta minus 1. So they take that and multiply it sort of like with the complex conjugate, even though it's not a complex conjugate. They're going to multiply top and bottom by, it's what? I don't know. Is that additive inverse or something? So cosine of theta plus 1 over cosine of theta plus 1. So this is the difference of two squares factored out. So if you FOIL those together, you get cosine squared theta minus 1. And then this one, like we do when we're doing the complex conjugate, you don't need to figure out what the bottom of it is. Cosine squared theta minus 1 is one of our trig identities, so you can replace that with sine squared theta minus 1. Okay? You see where this is going? No? Good. Okay, so now they're going to take and break this down again into two fractions. So they're going to take the sine squared theta and rewrite it as sine theta and sine theta. I don't know where the negative went. Anybody know where the negative went? Oh, it's in front of the limit, thank you, didn't see that, okay. So this limit we know already, sine theta over theta, the limit as that approaches 0 is 1. That's from our note card, that's 1, okay? And then the fun thing about this one is now that we don't have that theta on the bottom, we can just figure that out by substituting in 0 directly. The sine of 0 is 0, the cosine of 0 is 1, so that means to be a circle, not a 0. So then if you go -1 times 0 over 2, you get 0. Okay, and so that means that this right here is times 0. So sine of x times 0 cancels. Cosine of x times 1 is cosine of x. And so there is the proof, mathematical proof, of why the derivative of sine is cosine. Yes? How else would you have known that the limit as h approaches 0 of cosine of h minus 1? No, because then you'd have a 0 on the bottom and you can't divide by 0. So we had to find a way to get that to cancel first, and that's what all this craziness was for.
Way too much.
Okay? Way, way, way too much. Okay? But it does give us another important limit for us to know, another trigonometric limit. So really the moral of this whole story was to refresh your memory about this one, and then also give you this new one that you can put on your note card or in a prominent place in your notes.
What was
The old one is the limit as theta approaches 0 of sine of theta over theta is 1. Okay? So these are our two trigonometric limits that we are going to use to solve all of our trigonometric limit
So you want to turn
problems.
everything into.
So you exactly want to turn everything into either the cosine one or the sine one in order to solve these crazy problems that we're about to do. Okay, so let's do one. So let's find the limit as x approaches 0 of the sine of 7x over 4x.
Why
No.
are we back on limits?
Limits will never go away.
Oh.
There's no limit.
Oh, honey.
All right, so here's what we're going to do.
Wait.
As I was discussing or trying to get across with Pua yesterday, or what Connor was saying about the sine and the x, that's locked up with it, right? So I can't change the 7x to be anything else,
Yeah.
right? So that has to stay as a 7x. So for me to solve this problem, I need to get the bottom to be 7x also, because then I have like a sine theta over theta situation. You know what I'm saying? Okay, it's just sine of 7 times theta over 7 times theta.
So
as
now it's
long as
7,
they're
the
the
answer
same.
is 7.
Well, no, the answer to this would be 1.
Yeah.
Okay, but I can't just randomly change this 4 to a 7 and say the answer is now 1, right? Okay, so what did I multiply this fraction by to change it into this? No.
No.
The 4 is still on the bottom, but I'm just going to write it over here instead, okay? And then the 7 showed up randomly, so to balance out that 7, I also need a 7 on top. Okay?
No.
Okay? Yes,
So you
because
just
watch,
randomly
because
switch
watch,
it?
watch. Here's what I can do. I could cancel these 7s, right? And then what do I have?
Same thing.
I have the same thing that I started with.
Just multiply by 7.
Okay, so what I did to get it into this different form is I multiplied by 7 fourths.
Oh, I get it.
Because now that I have this as the sine of 7x over 7x,
I know.
technically what I'm doing is I'm saying, let's let theta equal 7x.
I feel like
Okay.
I could not understand.
So that means I can rewrite this as the sine of theta over theta times 7 over 4. And then this is going to be, what's the limit of the sine of theta over theta as theta approaches 0? 1. And 1 times 7 fourths is 7 fourths. Okay? Okay, so yeah, that's the type of problem that took me probably 3 years of teaching it to truly understand. No, maybe 2.5. To truly understand what's going on. Okay, but? So all you need to do when you're faced with this is you need to get the number, the thing on the bottom to match the thing that you're taking the sign of, and then figure
How
out.
much?
No, not too much.
I don't get it.
No, wait,
So
go
wait,
back.
nobody
Go back.
understands.
Yeah,
Nobody's
come on.
Can we do another one exactly like that?
Sure.
Yeah.
Nobody understands this. Nobody, why do you just get it?
Susan, why don't we try?
Why does it turn into?
Okay.
I'm confused, like what else, what do you
I
got?
want another one just like.
Wait, what
Get
was
it.
the point of that?
We solved that limit, that's what.
That doesn't make any
So
sense.
the limit's 7.4.
Yeah, so the limit's 7.4.
Wow.
That's the answer.
The eight,
So we work backwards.
Taylor, don't write this
Are you
down.
doing the
This
same
is the
thing?
same thing.
You said, can we do another one exactly like it?
okay, but I need to.
So I just changed the x to an 8.
That's not cool.
Okay.
Other numbers.
So let's do the limit as x approaches 0 of the sign of, pick a number.
4, 5.
5. We already used the 4. Over, pick a number. 2.
10.
Okay. So I need the bottom to be a what?
5.
5x. So I am going to randomly, magically change the
You just change
bottom
it
to be a 5x. Okay?
What's the point of like how?
Well,
why
the
can you do
point of it is if I have
Like,
sine,
why
the
can you just
point of it
randomly
is
change it?
if I have sine of 5x over 5x, now I know the
Because you
limit
can
is
just
that.
randomly
Oh.
change it. Why not do that the rest of the
You
time?
don't
Hold
have any of that.
Hold on.
He's shown us how.
What's the answer to this? 1. So that's the reason why I did it, okay? Now what Evan is saying is 100% true. I can't just change the problem to make it
But there's
easier, okay? I need to figure out what did I multiply it by to make that happen.
5 over 2.
Okay, right. So this 2 still has to be on the bottom, okay? Yes. And then since I introduced this, yes, you're correct. Since I introduced this 5 on the bottom, in order to cancel that out, I need a 5 on the top. Okay?
That's the
So
whole
Evan,
thing.
do you agree that the sine of 5x over 2x is mathematically equivalent to the sine of 5x over 5x times 5 halves? Yes,
Yeah,
because
yeah.
this 5 will cancel with that 5. 2 times x is 2x, and I have exactly what I started with.
All right, I get it.
Okay?
Made Evan
So,
really
since
tired.
these two things are the same, what's the limit as x approaches 0 of the sine of 5x over 5x? 1. And 1 times 5 halves is 5 halves, so my answer is 5 halves.
Can we
With which Patricia notices is what we started
it
with
always
in the
gonna be
first
like
place.
that?
I would never say always.
Most of the time.
Probably most of the time.
I would never say
There's always weird things that happen.
Can we not ever get in a math argument like that all of us?
Oh, that was not intense at all.
I didn't. I felt comfortable.
You felt comfortable. If Taylor felt comfortable.
Evan just kept yelling. I know, Evan got louder and louder. But why are we
Okay.
doing this?
All right, that's all been recorded for posterity. The great thing is that you didn't drop any F-bombs or S-bombs, or you didn't even say GD or any, you know. Okay, so like we were talking about before, you're maturing. It's been fun to get to know you over all
It's
these
true.
years.
You know what?
Okay, so let's do another one.
Last year, which was required.
Let's do the limit as x approaches 0 of x times the cotangent of x. And what does your math instinct tell you that you should immediately do,
Cotangent equals.
right?
Yeah.
I think so. Hold on, let me look. Negative.
Wait, the derivative cotangent?
What do you want
No, we're not taking the derivative, we're doing the limit. So I want to
Cosine
rewrite,
over sine.
right, I'm going to rewrite cotangent as cosine over sine, okay? All right, this is going to be like a huge stretch, what I'm about to do.
Well, the
Okay.
argument's gonna happen. I mean, it's okay.
Do you see in here this x over sine of x?
Yes.
Okay, so that is really similar to sine of x over x, except it's upside down, right? So we need to do some math to make it be sine of x over x, okay? So here's what I'm going to do. And this is going to maybe bother you a little bit. I'm going to take the top and divide it by x, and I'm going to take the bottom and divide it by x.
I don't like that.
Okay? And my motivation there again was I was really close to having the thing that I wanted, but I needed an x on the bottom, so I just put one there. But if I put an x on the bottom, then I have to put an x on the bottom of the top too. Okay? So essentially what I've done is I've multiplied the top and the bottom by 1 over x. And since I multiplied by 1 over x over 1 over x, that's like multiplying by 1, so I haven't changed it at all. Okay, so what can I do now on top?
Take out an X. Take out an X.
I can cancel the x, okay? And then one of the things that we learned about limits is that the limit of the quotient is the quotient of the limits.
Don't say that.
In other words, I can rewrite this as the limit as x approaches 0 of cosine of x divided by the limit as x approaches 0 of sine of x over x.
I remember.
Okay? What is the limit as x approaches 0 of, I should probably give you time to write it. Who was here, she'd be saying, slow down, slow
I'm
down!
ready.
Oh, Pooh's gonna be so lost.
No, but she can
She's gonna hear the
rewind.
argument.
She
She's
can
gonna get so
rewind,
lost.
she can replay.
She's gonna be like, what?
No, she'll be fine.
No,
She won't have Taylor here to distract her.
She's gonna get into that argument. She's gonna listen to the argument.
She can pause when she's like
Well, she's listening to
texting on her
it.
phone instead
Put up
of.
pause.
Okay, so the first thing that we can do is we can evaluate the top limit. What's the limit as x approaches 0 of the cosine of x? 1. Why?
Because cosine of 0.
Cosine of 0 is 1. I can plug the 0 in directly into that function because unlike this stuff here, I don't have to worry about dividing by 0.
Wait, what did you say the quotient of
The limit of the quotient is the quotient of the limits.
Oh, okay, now that makes sense.
That's like a riddle.
Kind of, yeah.
The limit.
And then what's the limit as x approaches
1.
0? Okay, that's 1. And 1 divided by 1 is 1. Okay?
Woo!
Yes.
Whoa, whoa, whoa.
So x over cosine over sine of x, that equals 1.
Say that one more time.
So like the first part, that.
Okay, never mind.
X over cosine of x, I mean x cosine of x over sine of x equals 1? No. What this means is that the graph approaches a value of 1 at 0. Okay, let's look at the graph. X cosine of x sine of x.
I don't get why that works, because it's like you're taking a constant and multiplies by 1, which doesn't change, and then turning like a 6.
It's magic.
You just put an X in there because it's doing.
Okay, so what I'm saying, Gabe, is that if we look at the graph of x cosine x divided by sine of x, the graph approaches 1 as x approaches 0. Okay, that's what the limit means. Now, if I look at the table here, if I look at the table here, you can see that there's an error at 0 because I can't plug in 0 here because the sine of 0 is 0 and I can't divide by 0. Okay? So this mumbo jumbo magic that we did was to get rid of that so that we could figure out what it was. What's that?
So you multiply by that like fraction.
Yeah, so I took this and I multiplied this by 1 over x and I multiplied this by 1 over x. And that gave me this. And I knew to do that because I knew I wanted sine of x over x. Just like with these other problems here, I knew I wanted sine of 5x over 5x. Okay?
But I can't.
Yes, so that I can end up with something that I can evaluate. Okay? So it's, I mean, it's the same thing as when you probably first saw multiplying by the complex conjugate to get rid of the square root on the bottom. That looks like
But then,
Well, that's the same, because the first time
then
we did
we
it.
did that crazy thing and the whole world was wrong.
Okay?
This is the first time.
And I have been accused of witchcraft in this class before. And that,
Okay, here's the thing.
Oh, it's in front of you.
Yeah.
Okay.
Okay, so you've already done the first, no, you've already done the first 3 of those, so you can skip those and then focus on the rest. I had an exchange student accuse me of witchcraft.
Who was it?
I think